Hello students, so this is 8-1, graphing quadratics. So let's say we have the equation y equals 2x squared. So how do we graph something we've never seen before? So much like what we did in the past, we are going to make a table. So let's go ahead and make an x and y table. And we're gonna plot about 5 points. So we're gonna use -2, -1, 0, 1, and 2 for our x values. The reason why we want to do this is because we want the few numbers that are around 0 so we can see the behavior of the graph. So what we have to do is we have to plug in these numbers into the x and then find out what the y is. So for the first one, it'd be 2 times -2 squared. And it's going to be the same thing for each one of this. So it's 2 times -1 squared, 2 times 0 squared, 2 times 1 squared, and 2 times 2 squared. So from orders of operation, we have to do the exponents first. So this is equal to -2 squared, which is 4, times 2, which is 8. All right, and then this is -1 squared, which is 1, times 2. So this is 2. Next is 0 squared, which is 0. 2 times 0 is 0. 1 squared is 1. 2 times 1 is 2. 2 squared is 4. 2 times 4 is 8. So these are our answers here. All right, so with this table, we're given 5 points. So let's go ahead and graph using those 5 points. So I'm just gonna make a graph right here on the side. I'm gonna go by 2s. 2, 4, 6, 8, 10. And then over here, I'm gonna go by 1s over here. So the graph is gonna be a little bit off, but I ran out of room, so I'm gonna use by 1s over here and 2s on the top. All right, so that's my graph right here. So let's plot our first point, -2, 8. -2, 8 is gonna be right here. And then -1, 2. -1, 2 is gonna be right here. And then 0, 0, that's at the origin, right there. 1, 2. 1, 2 is gonna be right here. And then 2, 8. 2, 8 right here. So we connected all the dots. Your graph should look like this. So notice how the graph is kind of like a U. Just make sure it's not a point right here. It's not gonna look like a V, but it'll look like a U. So that is how we graph a quadratic equation. So let's move on to the next example. Let's say we have the equation y is equal to x squared minus 4. So again, we are going to make a table. Right there, let's use -2, -1, 0, 1, and 2 again. All right, so let's go ahead and plug these values in for the x. So -2 squared minus 4, and then -1 squared minus 4, 0 squared minus 4, 1 squared minus 4, 2 squared minus 4. All right, so -2 squared is 4, 4 minus 4 is 0, -1 squared is 1, 1 minus 4 is negative 3. 0 squared is 0. 0 minus 4 is negative 4. 1 squared is 1. 1 minus 4 is negative 3. And 2 squared is 4. 4 minus 4 is 0. So we have our 5 points. Let's make our graph over here. All right, so these are going to be, each one is going to be 1. So our first point is negative 2, 0. So negative 2 zeros right here. And then negative 1, negative 3. Negative 1, negative 3 is right here. 0, negative 4. 0, negative 4 is right here. 1, negative 3. 1, negative 3, and then 2 zeros right here. So let's connect all of our dots. So this is what your graph should look like. And the most important part is just to have this table so we can just plug points in and see how the graph behaves. Even though you've never seen the graph before, we can still graph it. All right, so let's move on to the next example. Let's say we have the function f of x is equal to x squared, and then we have another function g of x is equal to x plus 3 squared minus 4. And then it's asking, what is the translation? All right, so we have to look at what the differences between these two functions are. So I see a plus 3 here and a minus 4 here. So when we are doing something to the input, which is to the x, it's going to be a horizontal shift, and it's going to be opposite. So this here is horizontal, and it's going to be opposite sign. So on a number line, usually plus would go towards the right side, but this here, it's going to be the opposite. So it's going to go towards the left. So it's going to shift left by 3. All right, and then this here, this is towards the output. It's towards this entire thing, this x squared. So it's going to be vertical. And usually on a y-axis, minus would be going down. So it would be shift down by 4. So if you have the graph, if this is given to you, you just need to shift this new one to the left by 3 and down by 4. All right, next example. Let's say we have the equation y is equal to ax squared, and we want to see what this a value does to our graph. So let's say this is our graph right here. This is y equals ax squared. So what will happen if this a value changes? So let's say we have y is equal to negative ax squared. So if a is negative, it's gonna be upside down. It's gonna look like this. So this is y is equal to negative ax squared. So if a is negative, it'll open down. All right, if a is negative, it opens down. So the reverse can be said. So if a is positive, it opens up. So this a is positive, it opens up. Also, if A is close to 0, it will be compressed. All right, so let's say our A is equal to 1/3. All right, so this is what it's gonna look like. The graph is gonna be squished. So this is the graph y equals 1/3 x squared. If our A value is closer to 0, it'll be like it'll open up a little bit wider. Same thing with, let's say if A is a big number. If A is a big number, the graph will look like this. Let me just make another one right here. The graph will shoot up really quick and it'll be really slim. So let's say this is y equals 10x squared. All right. So if A is a big number, it'll be skinny. So if A is a big number, the parabola, which is this u, it'll be super skinny. So we can apply these rules just from knowing this coefficient, this number in front of the x squared. So that's how your graph is going to behave based on that number. So I hope this helps you with the 8-1 homework. If you have any questions, send me an email or post your question on Google Classroom. Thank you.